Hi, we are going to be looking here at a problem involving the unit circle and the line y is equal to minus x. We're going to try to find all the points of intersection on the unit circle and that line. So if you are checking out my graphs here, remember the unit circle has a radius of 1. So every radius of this unit circle is 1. And that's what they call the unit circle. It's given by this equation, x squared plus y squared is equal to 1. So it's centered there at the origin, has a radius of 1. This blue line is y is equal to negative x. That's a line that goes through the origin. So its y-intercept is 0, 0, and it has a -1 slope. You can see that the intersection points are here in the second quadrant and the fourth quadrant. So one way we'll see to find those points is we can draw a line down to the x-axis from these points. What happens here is we make a right triangle. So I have a right triangle there in the second quadrant and a right triangle here in the fourth quadrant. Now you might observe that since this line has a -1 slope, it actually bisects this angle into two 45-degree angles. So this is a special triangle that we have here. We have a 45, 45, 90-degree triangle for each one of these. You may remember that when we have a 45, 45, 90-degree triangle, the ratio of the sides have a special ratio among them. So we have a 1 to 1 to square root of 2 ratio. Between the sides here and the hypotenuse. Let's go ahead and look at this triangle in the quadrant here. We know that the hypotenuse is 1. So this hypotenuse is going to go in by the 90-degree angle here. It's across from the 90-degree angle, and it's going to go with √2. We're trying to look for the sides of this triangle because if we can find them, we can actually find that point. So I often tell my students, how do you get from radical 2 to 1? You have to divide by radical 2. So if I have 1 on the hypotenuse to get the legs, I'm going to have to divide by √2. So each one of these sides is going to have 1 over √2 as its length. So we're going to have 1 over √2 here and 1 over √2 here. That's going to be the length. Similarly, in the second quadrant, I'm going to have those same values. So when I'm looking for the ordered pairs, I know in the fourth quadrant, positive and my y is negative. So one of the ordered pairs is going to be 1 over √2, comma, -1 over √2. So that's going to be one of the intersection points. It's going to lie in the unit circle and also on that line. Whereas in the second quadrant, I'm going to have my x value as negative. So -1 over √2, comma, +1 over √2. These will be my two intersection points. And you might see that I totally used trig here. I didn't use any algebra. If we were trying to solve this equation algebraically, we could definitely do it. We would just take this y is equal to -x, and maybe in the place of y, I would just plug in a -x here. That would make our equation x squared plus -x squared is equal to 1, I could solve for x, and then I would just plug back in to get y for each of my solutions there. So I could do this algebraically, but in a trig class, we try to do things a little more trigonometric. I don't know if that's the word, but we also take advantage of this ratio that we're going to be using a lot, the 45 to 45 to 90 degree triangle. So I hope this helped you with your problems there, and thank you.